hypothesis testing, z-test for mean, mu, critical value approach. Here's a possible research question. What is the average weight of newborn babies? And here's a hypothesis. Nursefields claims that the mean weight of newborn babies is equal to 8 pounds. So that's Nursefields' hypothesis. Now Nursefield wants to test that claim. Once he wants to test that hypothesis. He found the weight of 64 newborn babies, then calculated the mean and standard deviation. So here are the values that he calculated. The critical value is minus 1.96. The sample standard deviation of the 64 newborn babies was 7.4 pounds, and the standard deviation is 2.87 pounds. All right. So step number one, as we know, step number one is always to state a pair of hypotheses, but we have to convert that hypothesis in symbolic form. Okay. So the keyword there is mean and is equal to. So we can begin converting to symbolic form, stating the pair of hypotheses. So you have the HO and the symbol for mean. Go to insert symbol for mean, and we have to put a symbol there and 8 pounds. Okay. Then you have the HA. Colon, the symbol for mean. We have to put a symbol there and 8. So for us to know what symbol to put there, we have to look at this word there, is equal to. Okay, is equal to. What is the symbol for is equal to? Okay, because we have the symbol for mean already, here it is, and we have the number 8. So what we're missing is the symbol for is equal to, and that will be our pair of hypotheses, converting this worded hypothesis to symbolic form. So to get the symbol for is equal to, we go to this table there. This table have all the symbols for all the words that may mention, and we look for is equal to. So here is equal to, the mean is equal to, so you can say is equal to, you can say is, or you can say exactly, and here's the symbol for it, is equal to. Now the equal sign is for the HO. The HO always carries the equal sign, as you can see, and the HA now carries the not equal sign. So the equal, we must put it for the HO. If you notice, the HO always have the equal sign. So is equal to, this one is less than or equal to, here it is. This one is greater than or equal to, and this one is equal to. And then the HA carries the not equal sign. So we have to put is equal to here and not equal to here, the opposite of is equal to. All right, so to get the not equal symbol, we go here. Right, now, although this is optional, but we can state that the HO was the claim. All right, that's what Nursefields was claiming. Okay, it's optional, but you don't have to write it. That is what was claimed. So that is what we're trying to test to see if it is true or not. Okay. So that's step number one. Now, step number two, step number one. Step number two now. We have to sketch a distribution curve. All right, here it is. Step number two, sketch a distribution curve. Step number three, we have to shade a critical region. Okay. Shade the critical region. And step number four, place a critical value on the critical region. So we have 3 steps to do there. And we can call it step number 2, 3, and 4. Okay. So here's the curve. It's a normal curve, and since is not equal, the HA carries the not equal sign, so it's a two-tail. Remember, the rejection region depends on the HA symbol. So because the HA is a not equal, then we have to take the two-tail curve. All right, two rejection regions. Always bear in mind for the z-test for mean, the critical region depends on the symbol for the HA. And in that case, the HA is not equal. Okay, so therefore now it's a two-tail. Let's put this in a text box. So we have step 2 and 3. We have the curve and we have the critical region shaded on both sides. So what we're missing now is to put the critical value. The critical value will be provided. Bear in mind, we call this the critical value approach. Okay, so it's the critical value we have to be using here, and the critical value will be provided, and the critical value is minus 1.96. There it is, the Z critical value, negative 1.96. So we have to put the critical value, negative 1.96, on the critical point, minus 1.96. Okay. Now we have to represent the critical value in two regions, both on the left and on the right. So therefore now we have to put the negative 1.96 on the left side of 0. Bear in mind for the normal curve, this center here is 0. Okay, so on the left side of 0, you have negative 1.96. And on the right side of 0, we have positive 1.96. Okay, so that's a two-tail because of the not equal sign. Okay, the rejection region always follows the symbol of the HE. Okay, now step number 5 now is to calculate the test statistic. Okay, step number 5 is to calculate the test statistic. Here's the formula for the test statistic, the z-test statistic. Okay, so we have placed the z critical value on the curve already. It's now to calculate the z-test statistic. Here's the formula for it. Okay. Now to calculate the z-test statistic, we have to use the 4 values that were provided. And these values will be given to you, so you don't have to look for those numbers. They will be provided to you. Here they are. We're calculating the z-test statistic is equal to the sample mean. The sample mean is 7.4. Here it is, X bar, and the population mean is 8. So 7.4 subtract 8 in the numerator. 7.4 subtract 8. All right, 7.4 subtract 8. And in the denominator, we have the standard deviation divided by the square root of n. The standard deviation is provided. Here it is, 2.87, and n is 64. So it's 2.87 divided by the square root of 64. Okay, and the square root of 64 we know is 8, but we can put the whole formula in our calculator to get the z-test statistic. So we have a fraction there. We have 7.4 subtract 8 divided by another fraction, which is 2.87 divided by the square root of 64. As you can see, I put in everything one time in the calculator, and you just click enter, and we get in a value of negative 1.67. Here it is, negative 1.67. So that's the z-test statistic, negative 1.67. So step number 6 now. Let's put step number 6 there, because step number 6 says that we have to place the z-test statistic on the curve. So we have to go back to the curve with the z-test statistic. Bear in mind, this is the critical value approach. So we're comparing the critical value with the test statistic. Okay, so the critical value is negative 1.96 and 1.96, and the test statistic now is negative 1.67. All right, the critical value approach, we're comparing the critical value and the test statistic. So negative 1.67 comes here. All right, right here. So as you can see, the test statistic is not in the critical region. Okay, the test statistic is not in the critical region. All right, there it is, right there, just to put the point to indicate anywhere around there, because negative 1.67 is closer to 0 than negative 1.96. Negative 1.96 is the critical value. It's on the point, critical point, and the test statistic is between negative 1.96 and 0 in the unshaded region. So we go into step number 7 now. Step number 7 says we have to decide either to reject H or not. Reject the null if the test statistic is located in a rejection region or shaded region. Do not reject the null if the test statistic is in the unshaded region. So because the test statistic is in the unshaded region, we do not reject the null. Okay, so we are not rejecting the null, because if you notice, our test statistic is not in the rejection region. It is not in the shaded region. It is not in the critical region. Okay, the test statistic is not in the critical region. So the decision is not to reject the null hypothesis, and the null hypothesis is HO. Bear that in mind, because the test statistic is not in the critical region. Okay, this is, remember, this is the critical value approach. So we compare the test statistic and the critical value. Okay, so step number 8 now is to conclude. So it says, if the null is rejected, then the alternative statement is the conclusion. If the null is not rejected, then the null itself is the conclusion. So when we go here, we did not reject the null. Okay, so therefore the null is the conclusion. So since we did not reject the null hypothesis, it itself is the conclusion. Therefore, so you have to state it now. So what the null is saying, let's go back to the null. Remember, you always start with 2 and you end with 1. One of them is the conclusion. We start with 2 statements. 1 is the conclusion. So we did not reject the null. Right, here's the null. We did not reject it. So therefore, it is the conclusion. Okay, the mean is equal to it. So that's the conclusion. Okay, the null is the conclusion because we did not reject it, and we have to state it. So therefore, the mean width of the newborn babies is equal to, or we have to state the conclusion in words, is equal to 8 pounds based on the data. All right, based on the data. You must end by saying based on the data. Okay, so here you have it, the 8 steps for z-test for mean using the classical approach. From stating the pair of hypotheses to concluding. one of the statements, one of the hypotheses will always be the conclusion.